Okay, we're going to wrap up our conversation about mass spectrometry with a very useful topic. And we're going to call it degrees of unsaturation, or HDI, Hydrogen Deficiency Index. Now, remember, mass spec is used to determine the molecular formula, right? Determine the molecular formula of an organic compound. IR is for functional groups, right? But we're talking about mass spec here. It's molecular formulas. We're interested in that. So in alkanes, typically have the general formula of CnH2n plus 2, right? Remember, methane looks like that, where n is equal to 1, 2n plus 2 is equal to 4, right? Ethane is C2H6, where n is 2, right? That's where I'm getting my n. 2 times 2 plus 2 is equal to 6, right? Which is there. So a saturated alkane, or alkanes which are saturated, follow this formula, CnH2n plus 2. So if we can count the hydrogens and the carbons in a compound, or we get some hint about what they are, then we can sort of break it down and find out if we have the right ratio for alkanes or alkenes or alkynes. Let's look at a specific example. So look at pentane. Pentane is C5H12, right? So a degree of unsaturation, that is if we are missing two hydrogens, we're missing sort of an H2 molecule, right? That's 1 degree of unsaturation. That would be a pi bond. So this, can you see, I'm missing two hydrogens, right? And that's 1 pi bond. If we miss 2 more, that would be another pi bond. So this has 2 degrees of unsaturation, right? Or the HDI index is 2. Okay? So this HDI index is equal to 1. Okay. So the HDI index of this is 0 because there's no deficiency, right? This is a purely, someone is whistling in the background of my house, and so that's what that little whisper was about. All right, so back here now, HDI index is 0. Sorry, got a little distracted by the whistling. HDI index here is 1. There's 1 degree of unsaturation. HDI index here is 2. There's 2 degrees of unsaturation. Every time we're too short of a hydrogen, that means we've got 1 extra pi bond or a ring. For example, cyclopentane is a ring, right? There's no double bonds, but a degree of unsaturation could still be a ring because this is C5H10, right? And if it were that, it would be C5H12. So again, when we are missing 2 hydrogens, that means we either have a ring or we have a pi bond. So let's take, for example, C4H6. Well, in C4H6, n is equal to 4 because it's right there, right? 2n plus 2 is equal to 2 times 4 plus 2 is equal to 10, right? And so C4H6, we don't have 2n plus 2, we actually have 6. So it looks like we're missing 4 hydrogens. And so if we were missing 2, it would be 1 degree of unsaturation. So 4 divided by 2 is equal to 2 degrees of unsaturation. So the HDI index for this is 2. And that means if we have C4H6, that means that we have either, let's see, C4, right? We could either have a triple bond, right? That would be C4H6, or we could have a triple bond here. Well, you know what? The next slide's got some pictures of things it could be, right? We could either have 2 double bonds. That would be C4H6. Or 2 that are right in a row, C4H6, or triple bond, right? Triple bond. We could have 2 rings, right? Or we could have a ring and a double bond, or another ring and a double bond, right? You see, there's lots of ways we can get 2 degrees of unsaturation, but it certainly gives you some hint about the structure, right? Strictly by getting the molecular formula. All right, so again, 1 degree of unsaturation is 1 unit of the HDI. Let's go and look at some other things that could be useful to you. If you have a chlorine in a molecule, it takes up as many bonds as a hydrogen, right? So for the HDI scale, a halogen is treated just as if it were a hydrogen because it takes up exactly the same number of bonds as a hydrogen would, right? Now, oxygen doesn't take up any extra bonds at all. So for ethanol, you have 6 hydrogens, and for ethane, you have 6 hydrogens, right? So if you have an oxygen, it doesn't affect your HDI. If you have halogens, it does affect HDI. You just add one as if it were a hydrogen, right? Watch this. Nitrogens is interesting. Nitrogens actually takes up 2. So ethane has 6 hydrogens here, but here it has 7. Okay, so these are some things you can think through intuitively. There's a formula here, of course, that will work nicely. The HDI, the Hydrogen Deficiency Index, can be simplified. I don't know if you'd call this simpler or not, but 2 plus N minus H minus X, where X is a halogen, right? Halogen, and N is the number of hydrogens. H is the number of, I'm sorry, N is the number of nitrogens. My handwriting is terrible, right? That's hydrogen. That doesn't help you. That's hydrogens, that's nitrogens, and that's carbons. And that'll give you your degrees of unsaturation. All right, so write this down, practice with it a little bit, and prove to yourself that it's useful.